Hey Jade, it's Mrs. Vara. I thought the easiest way to answer your question was just to make a video. So I'm first going to look at that question you had from the video you were watching. And so this is the step where I think you had your question when he was checking the endpoint -1. So he has this in the video. He simplified it to this, which simplifies it to this. So now the question here is, does this converge or diverge? And then he uses the limit comparison test, and he is comparing to this series 1 over n. So that's that harmonic series, which pretty much you just have to memorize that this series always converges. So then the test he's using, remember, to try to see what's happening to this, is this limit comparison test. So this says if you take the limit as n approaches infinity of one series over another series and you get a limit, then whatever the... let me stop this call for a minute. Okay. If you get a number limit, then the two series do the same thing. So either they both converge or diverge. So we know that this function diverges. So if we do the limit comparison, so the limit as n approaches infinity, and I think he did this function, or this series, divided by this one. Sometimes it does remember, whoops, that should be a 3. It does matter which one you divide. I think he put the 1 over n plus 3 on the top. So then remember, dividing fractions is the same as multiplying by the reciprocal. So this is going to become n over 1. And then if I simplify that, I end up with n over n plus 3. And so if I'm going to infinity, these have the same power, power of 1, power of 1. So what I approach are the coefficients. So this limit equals 1. So because I got a limit, the limit comparison test says if you get a limit, then both of these series are doing the same thing. So because we know this series diverges, then we know this series diverges. So even though you get a limit, the limit just tells you the two series do the same thing or behave the same way. So that's why that one diverges. And then I started to look at the problem you were working on. I think you said you started with the ratio test. So this is the ratio test on the problem you were working with. And you could kind of just pause the video and follow my steps. But ratio test, I'm going to do the limit of x to the n plus 1 divided by x to the n. So I already did the multiply by the reciprocal. And then I want to rewrite these like I did here. -1 to the n plus 1 is the same thing as -1 to the n times -1 to the 1. So I'm splitting that. I'm splitting this into x plus n times x to the 1. And then these I kind of wrote over or underneath these because they go together when I'm simplifying. N plus 1 plus 6 I wrote as n plus 7, and I put it with the n plus 6. So now if you think about simplifying, those divide to give me 1, those divide to give me 1. So what I'm left with here is -1 to the n, which is just -1, times x, times all of this, which I have here. Now think if you take the limit as n goes to infinity, this is going to approach 1. I have the same power over the same power. So my limit is my coefficients. My coefficients are 1. So all of this approaches 1. So I'm left with absolute value of -x. For convergence, that has to be less than 1. So this is my, what I'm going to call my first interval of convergence. And then you want to go ahead like he did in the second part of his problem here and check the endpoints. So I hope that helps. Let me know how it goes and if you have more questions.